Let's look at a question. A cubical block of steel, each of side equal to L, is floating over mercury in a vessel. The density of steel is given as rho s. The density of mercury is rho m. We have to determine the height of block above the mercury level, and the options are given. Then for solving that, let's draw a vessel. This is our vessel and it is having mercury filled up to this mark. Let's call the density of mercury as rho m. Rho m is density of mercury. Then let me adjust the focus. Okay, then we are having a cubical block inside it. This is our cubical block and its side length is L. Cubical block's side length is L. It is immersed inside the fluid. Let's call the density of this cubical box as rho s, since it is made of steel. It's made of steel. Then it is having x distance above the mercury level. Then if this distance is L and if this distance is x, then we could say this distance, it will be L minus x. Let me write L minus x over here. This is L minus x. Okay, then L is the length of this cubical block, x is the distance it is above the mercury, and L minus x is distance below the mercury. Therefore, if we are analyzing the forces acting over this, the gravitational force, it will act vertically downwards. Then buoyant force, it will act vertically upwards. And if it is remaining like this, it is in a state of equilibrium, and at equilibrium we could say the net gravitational force is equal to the net buoyant force. And substituting gravitational forces, we could write it as mg. M is the mass of this block, steel block, and buoyant force, according to Archimedes principle, we know magnitude of buoyant force is equal to the weight of fluid displaced. Magnitude of buoyant force is equal to weight of fluid displaced. Therefore, buoyant force will be equal to weight of fluid displaced. Let me write it as m dash g. M dash is the mass of mercury displaced or mass of fluid displaced. We could cancel out this g. Then mass can be written in terms of density as density is equal to mass by volume. Therefore, mass is equal to density into volume. And this mass is equal to density, that is density of that substance into volume. Since it is a cube, volume can be written as L cube. L cube. Then m dash. M dash is the mass of fluid displaced. Mass of fluid displaced, it will be exactly equal to the volume of that substance inside the mercury. The volume of that steel block inside the mercury, or the shaded portions volume. Shaded portions volume, we could write it as volume is base area into height. Base area is L square into height is L minus x. That is volume into density. Density is, we have to write the density of fluid, that is density of mercury. Then we could cancel out this L cube, L square, and we have to write an L over here. Then if I am retaining this L minus x over here and taking this rho m to this side, we could write L minus x is equal to rho s L divided by rho m. Okay, we have to determine the x value. Therefore, minus x is taken to this side. X is equal to L. This is taken to this side, means minus rho s L divided by rho m. Taking L out, 1 minus rho s by rho m, rho s by rho m, and this is the height of cubical box above the mercury. And by looking at the options, we could see option B is correct.